factoring a polynomial and factoring out the greatest common factor, or the GCF. And remember, when you're doing the GCF, you need to have, for the numerical part, the highest common factor that all the numbers have in common. For the variable part, it will be the variable with the lowest exponent. So here's an example, a more complicated example of a greatest common factor. So I'm looking at the numerical part, and I see that 15 can divide into 30, and 15 can divide into itself. So the GCF of the numerical part will be 15, and the variable part will be the variable with the lowest exponent. So we get x squared and y squared as the variable part. So my GCF will be 15x squared y squared. Now, when you're factoring out the GCF, you're going to start by writing the GCF on the outside of an open parentheses. And then you're going to take each term and divide the GCF out. And whatever's left will go inside the parentheses. So when you see the first piece here, when I divide the GCF out of 15x squared y to the third, you see the 15x squares will cancel out, and when I reduce the y to the third over y squared, I'm left with the y. So that piece will go inside the parentheses. And then I'm dividing it out of the 30x to the fourth y squared. And you see 15 goes into 30 twice. The x to the fourth and x squared will simplify to x squared. Pause and try. So the GCF here is going to be that 2py. Now you're dividing it out of each term, so the first piece will end up being 7py minus 4y plus 1. You have to have that plus 1, otherwise when you redistribute it, you will not get what you started. So 2py divided by 2py equals 1, and you need that position in the parentheses. So do not forget to put the plus 1 or the minus 1 in some cases. Now, when you see something like this, and it's asking us to factor out the greatest common factor, or the GCF, you have to be careful here, because instinctually we want to do the distributive property and combine like terms. But what we really have here is a GCF, and the GCF is that common binomial. That common binomial is the greatest common factor for these two terms. So you're going to take that and you're going to write it on the outside with an open parentheses. And then you're going to take and divide out that common factor, that GCF, out of each term. Now you see here, when I divide the 2 parentheses x minus 5 by parentheses x minus 5, I'm left with simply the 2. And then when I divide it out of the 3x parentheses x minus 5, I end up with just the plus 3x. So the GCF in this case happens to be a binomial, and when I factor out the binomial, I get another binomial. Pause and try. The GCF here is that common binomial of y plus 4, and what's left in the other binomial is going to be that y squared plus 6. So now we're talking about factoring special factors, and this is the difference of squares, the difference of squares. And what that means is that I have 2 perfect squares in my factoring. So if you look at this difference of 2 squares, it's going to factor to the square root of the first thing plus the square root of the second times the square root of the first minus the square root of the second. So this is the sum and difference, or the difference of two squares. So when you're asked to factor this special type of factoring, you're going to use the plus and minus, and you're going to take the first term and square root it, and x square rooted is simply x, and that would be my a term. And I'm going to take my last term and square root it, and the square root of 121 is 11, and I'm going to place it in the second position. So this is the sum and difference, and when I re-multiply it, I will get the difference of two squares. So when you're doing special factoring, keep this in mind. When you have an x squared minus a number and there's no b term or no middle term, you might have the difference of two squares. Pause and try. So when you factor this, you end up with x minus 9, x plus 9. Or you could have the x plus 9 first and the x minus 9 second. The order doesn't matter. Pause and try. So now this one's a little tricky because your a is a 25x squared. So when you square root that, you're going to end up with 5x, and then the square root of 16 is 4. So you end up with the difference of two squares is 5x minus 4 and 5x plus 4. Or again, you could have the 5x plus 4 first and the 5x minus 4 second. Now in this case, we have both factoring the greatest common factor and the difference of two squares. If you're looking at something that you think might be the difference of two squares, but when you look at the terms, neither one of them are perfect squares, think you might have a GCF. So in this case, I see that I have a GCF. 3 can divide into 48. So I'm going to first factor out the GCF. So when I factor out the GCF of 3, I'm left with x squared minus 16. And now x squared minus 16 is the difference of two squares, and I can factor it. Now be really careful, because when you factor it, you have to make sure that that GCF is in your answer or attached to the first parentheses. So we end up with 3 parentheses x plus 4 parentheses x minus 4. Pause and try. So in this case, my GCF is 12 here. I factor out 12. I see I have the difference of two squares, and then I factor it into x minus 3, x plus 3. And again, don't forget to include your GCF in your answer. So it's 12 times x minus 3, x plus 3. Pause and try. So again, your GCF here is 2. I factor out the 2. I see I have the difference of two squares. And then I factor the difference of two squares. And I get 2x plus 6 times x minus 6.